This meeting is being recorded.
Okay, so we will start with the third lecture on unit number 3. So in the last lecture, what we have seen is we have seen introduction of knowledge, representation, and reasoning. Then we have also seen the artificial intelligence knowledge cycle. This block diagram is almost all AI system consist of these components in the block diagram in order to create an intelligent machine. So what does this block diagram consist? It consists of perceptions, learning. Then the second block is about knowledge, representation, and reasoning. Then we have planning and then execution. So you know that perception is very important, which is nothing but the collection of the information from its environment or other sensory information. Learning actually is nothing but adaptive and helps to perceive the data. Knowledge, representation, and reasoning means nothing but to represent the meaningful representation, which could be either static or coupled with learning components. And then we have a planning, which is nothing but information that is used to plan a course of action. And then execution is nothing but which enables machine to perform the intended task. So this is very important, and hence I am repeating once again, this is an AI knowledge cycle. And we have seen what is knowledge representation. So knowledge is nothing but taking the world to be one way, not the another way. And then representation is nothing but it is nothing but the representer, which may be an immediate, very concrete, immediate, or accessible, that is in form of second. The example we can take is a digit 7, which looks like, which can stand for number 7, or it may be as an a group of letters, that is 7. So as we know that representation is nothing but that is through the symbol representation that recognizes, distinguishes them from each other and display them. Then this is how the example we have taken about the benefits of representation. So you can see different symbols standing for the things in the world. Then we saw KR, which is nothing but a knowledge representation. It is nothing but symbolic encoding by some agent of propositions believed. The main research that is going on in the knowledge representation is nothing but the representing knowledge about the application areas like medical knowledge, knowledge about time, knowledge about physical systems, developing appropriate representation languages, specifying and analyzing reasoning over represented knowledge, and then implementing a system that supports representation of knowledge and reasoning over the represented knowledge. So two things to take out from here is the system is nothing but representation of the knowledge, and then the reasoning over the represented knowledge. So if you look at the most important two things is that the knowledge representations assumes an explicit and declarative representation. So what is the explicitness is? The explicitness is that the represented knowledge is stored in the knowledge base. And declarativeness means the representation that can be specified without reference to how the knowledge is applied procedurally. That is nothing but implying some sort of logical method behind it. Then we saw reasoning. Reasoning is nothing but the formal manipulation of symbols, that is representing collection of believed propositions to produce representations of a new ones. So reasoning is actually a form of a calculation, not like an arithmetic, but it is nothing but over the symbols standing for the propositions rather than numbers. Then that means reasoning is a manipulation of symbols encoding propositions to produce representations of the new propositions. So this is the examples of benefits of reasoning. So you can see that there are two
Yeah.
types of calculation. One goes with arithmetic and the other goes with the symbolic reasoning. So arithmetic reasoning and symbolic reasoning. So this is what it has been applied in case of artificial intelligence systems. So we have also seen KRR in AI. So KRR is very, very important as in the field of artificial intelligence. This KRR represents the information about the world in the form that can be utilized by the system to solve complex tasks. So what can be the task? It may be diagnosing the medical conditions, problem solving, or knowledge reasoning, and much more. So most important thing is that all these three parameters, that is knowledge, representation, and reasoning, should go hand in hand. That should work hand in hand. So if they work hand in hand, then we can get the specified task completed which we have assigned. That is what is the most important thing. Then we started with the detailing of a knowledge representation, so which is nothing but the sub area of artificial intelligence concerned with understanding, designing, and implementing way represent information is represented in computers that can be utilized by agents to perform varieties of tasks. So the task may be converse with the people in natural languages. Then we have determined the course of action, the plan future activities, perform human-like problem solving. So we have also seen what are the approaches of a knowledge representation. So one we have seen simple rational knowledge. The other one we have seen inheritable knowledge. This is the example of the inheritable knowledge. Then we have seen inferential knowledge. So with the help of two examples, we have seen Marcus is a man and all men are mortal. So you can see that how it is represented. This inferential knowledge actually guarantees the correctness of the system, and this approach can be used to derive more facts. Then we have also seen procedure knowledge, which is nothing but which follows an important rule called as if then rule. And in order to code in these kinds of procedure knowledge, we can use different coding languages such as LISP, Fortran, or it may be a Prolog language. It can be easily represented as heuristic or domain specific knowledge, and it is not necessary that we can represent all cases in this approach. This is what the limitation of this procedure knowledge is about. And then we just were starting knowledge reasoning. So we have seen first the knowledge representation. Now we'll actually, from this lecture, we will, in this lecture, we will start the knowledge reasoning. So knowledge reasoning is like knowledge representation and knowledge reasoning are two different things. In this part we are going to see how differently it is. Knowledge representations can further explained be with the help of the example, like let's imagine a boy playing in a game of a chess against a computer. Now if we go with the knowledge representation and reasoning, then playing a boy with the chess against a computer is nothing but KRR. And here the boy will use his knowledge of a game as well as reasoning to beat the opponent, whereas the computer will be dependent on the data or the information provided to it, right? So there are two things. If I'm playing a chess with a computer, the computer has very specific designed steps that have been given to it, but that doesn't happen with me, because I can, depending on the situation, I can take every kind of decisions to move. So we can say that the opponent is a computer. The computer will be dependent on the data or the information provided to it, outnumber the winning moves of a boy. It is here that knowledge representation and reasoning will come into the play. It is the responsibility of a KRR to express knowledge in the computer or machine in a way that allows machine to perform the required task. In short, we can say that KRR replicates human intelligence behavior and makes the machine capable of outperforming the former. So obviously it will be thinking like a human. So everything will be like a human. The human intelligence will come into the picture. And because of knowledge representation and reasoning, this could happen. The other examples of knowledge representation and automatic reasoning is semantic nets, system architecture, ontologies, rules, frames, inference engines, automatic theorem provers, and the classifiers. These are some of the examples where knowledge representation and automatic reasoning can be applied. Now, what are the types of knowledge representation? So how we are going to go with the types? So obviously, if you look at the block diagram, you can understand from this block diagram, there are almost 5 types of knowledge representation. If you want to understand various levels of knowledge representation and the impact of AI, we have to actually go on the functionality knowledge that is represented through different 5 kinds of categories of the knowledge. So one is a declarative knowledge that is about the objects and facts, heuristic knowledge that is about the rules of thumb, meta knowledge that is about the knowledge about the knowledge, procedural knowledge that is rules for the procedures, and then the structural knowledge called as relationship between objects and concepts. Now these 5 kinds of knowledge is very much important to represent the knowledge. So that is called as the knowledge representation. Now let us see one by one what are these knowledges. The first one, if you'll see, declarative knowledge is an about a statement that describes a particular object and its attributes, as well as some behavior in relation to it. So if you could see that there is a particular object and there are some attributes of it. So the particular object with the attribute and the behavior in relation to it is very important. That means there is an object, there is an attributes. Now, an object and attributes, how you're going to relate them with each other. So obviously, in order to relate with each other, we need to have some kind of behavior in relation to it. And while doing this, we can use declarative type of knowledge. This type of knowledge representation is expressed in declarative sentences, which includes concepts, facts, and objects. So obviously, when you're going to express this kind of knowledge, you need to have the expressions like declarative sentences, and that should include concept, facts, and objects. Second is a procedural knowledge. The second type of knowledge representation is a procedure. It is about details of knowledge about how to achieve something. So procedure, like procedure to apply to achieve something. The first is about the concept, facts, and objects. So in declarative knowledge, there will be declaration of concepts, of the facts, and the objects. In case of procedure knowledge, now we are going to have the knowledge about the procedures to achieve something. The knowledge is based on the task on which it can be applied. It is used to describe how a problem can be solved, as well as direct the steps to perform a task. So step by step, you can be given an information about how to achieve that particular task. That means some kind of procedure will be given. The procedural knowledge derives information or knowledge based on rules, agendas, strategies, or procedures. So पहले declarative knowledge में आता है concept, facts, and objects. दूसरे में आता है knowledge based on rules, agendas, strategies, or procedures. So these are 2 types of knowledge representation. Now the third one is a meta knowledge, which is nothing but the knowledge about the knowledge. It provides knowledge about other types of knowledge that are suitable for problem solving, because it doesn't mean that only one problem is helpful to solve a particular task. It may be required another problem. So at that time, you should to have another knowledge. You should to have a knowledge of other types of knowledge also. So it is not about a particular knowledge. So if that is being there, that will be suitable, which will be suitable for problem solving. Moreover, it enhances the efficiency of solving problem through proper reasoning process. The other types of phases obviously includes planning, execution, are dependent on the analysis of knowledge representation and reasoning. So what is meta knowledge? It is about knowledge about the other type of knowledge. It is the knowledge about the other types of knowledge which is suitable for problem solving. Then comes heuristic knowledge. It is based on the thumb rule. Heuristic knowledge provides information based on strategies that may be compiled by experts to solve the problems through experience of past problems. So obviously, heuristic is related with the past issues, that how they have been solved the issues, and the same is applicable if such kind of issues appears in the future. It is useful in guiding the reasoning process. Then the fifth one is a structural knowledge. Structural knowledge is the basic knowledge that is based to solve the problems, as it describes the existing relationship between concepts or objects. So the structure is there, some kind of like that. इस स्ट्रक्चर का उस स्ट्रक्चर के साथ क्या रिलेशनशिप्स है. So the relationship between concepts or the objects is been shown through the structural knowledge. It is associated with the information based on expert systems, concepts, and knowledge. So once again, we'll revise this one. Knowledge reasoning, we have seen how KRR can be applied. So the best example is to imagine a boy playing with a game of a chess against the computer. So obviously the boy is going to use his intelligence based on the learning what he have received. Similarly, the computer will be dependent on the data or the information provided to it. So this means that KKR is going to help artificial intelligence or human intelligence behavior to mimic in machines. Then types of knowledges. So obviously based on the various levels of the knowledge representations, we can have 5 kinds of knowledges. First is a declarative knowledge that is based on concepts, facts, and objects. Procedure knowledge, which is based on the rules, agendas, strategies, or procedures. Meta knowledge is about the knowledge about the other types of the knowledge that is suitable for problem solving. Heuristic knowledge is nothing but it is the information based on the strategies or compiled by the experts to solve the problems through the experience of past problems. Overall, it will be helpful in guiding the reasoning process also. And the structural knowledge is about the information based on the expert systems, concepts, and relationships. Actually, structural knowledge gives you the existing relationships between concepts or the objects. Now let us move a little bit further. We are actually in the knowledge, representation, and reasoning. So obviously these 3 factors is going to make the machine intelligence. So it is about representation of the knowledge and then reasoning about the knowledge on represented knowledge. So now we'll little bit move forward. We have seen a lot of things about the knowledge. We have seen about the representation of the knowledge. We have also seen about the reasoning. Now the time has come to understand a relation between knowledge and intelligence, because to having the knowledge, to represent the knowledge, to apply the reasoning is somewhat different. But when I say a calculation as an intelligence, then I need to know what is actually knowledge and what is intelligence. So let us understand this relationship between knowledge and intelligence. As we know that knowledge plays an important role in intelligence, as well as same for creating AI. Knowledge plays an important role in demonstrating intelligent behavior in AI agents. So if I'm having a knowledge and I'm going to demonstrate it, then you will be saying that yes, he's having an intelligent behavior. So actually I'm demonstrating my intelligent behavior through my knowledge. So overall, centrally, if you could say that knowledge becomes a very much important role in demonstrating intelligence. In case of AI, agent plays a very important role. So when an agent is having that kind of knowledge, it will help you to demonstrate the intelligent behavior in machines. Agent is only able to accurately act on some input when he has some knowledge or experience about the input. So what agent does? We know that we have seen agent. So if some kind of input is to be given them, so agent, according to his knowledge or experience, he will act on that input. Now let us take an example that if you meet some person who is speaking in a language which you don't know. Suppose there is another language like a Japanese language. If I'm speaking English and there is another person who is speaking in Japanese, then how I will be able to act on that? The same thing applies to the intelligent behavior of the agent. So the agent cannot is not able to accurately act if it does not have the experience or the knowledge about that input. So it is not possible. He should have the knowledge or experience about that input, and then only agent will act intelligently. Or I could say that it is an intelligent agent. So same thing is applied here. This is the best example to understand. So if 2 persons are understanding each other because they know they are having the same languages, that means one person is knowing the knowledge about that language or experience about that knowledge, then only he can understand. So this is what it is applicable to the agent also. Now let us understand through this figure how the knowledge and sensing and actions are work together with the help of decision making. As we can see in below diagram, there is a one decision maker which acts on the sensing of the environment. So sensing is done to the decision maker. A knowledge is also taken from the decision maker. But if the knowledge part will not be present there, it cannot display the intelligent behavior. So obviously, I'm sensing something. I'm a decision maker. If I'm not having any kind of knowledge regarding this sensing, then the action will be not an intelligent action. Simple way you can make it. So knowledge becomes very, very much important part as far as intelligence is concerned. To have an intelligent behavior, I should have that knowledge about that input. How categories are useful in knowledge representation? So you can see that there are four categories. One is a logical representation. The another one is semantic networks. The third one is the production rules. The fourth one is a frames representation. These are the knowledge representation techniques. Classification schemes and categorization is an integral part of representing knowledge. Obviously, if you want to classify or categorize some of the classes, then how you're going to go? You need to have classification scheme, you need to have a categorization scheme, and that will help to represent the knowledge, and obviously any knowledge based systems in order to perform any task, and they can solve the problems accurately based on the details of the information. This is what the categories are important. This is how the knowledge representation techniques are important. These schemes have properties that enable the representation of entities and relationships in data structures and reflect the knowledge of the categorized domain. Moreover, this categorization is in terms of ability of the structure to reflect, discover, as well as create new knowledge, which further increases its value in the knowledge representation. Clearly, if I say that if I'm having a particular knowledge and based on the input, I'm going to apply my knowledge. Now, categorization actually helps me to create a new knowledge, which will further improve its value in the knowledge representation. That is what the knowledge representation techniques can help with. So now let us see one by one how these categories or four techniques of knowledge representation are going to help. The first one is a logical representation. It is the first knowledge representation technique, which is a language with set rules that are used to deal with the propositions. Now let us again take an example of a person who is speaking in a particular long language. So how he can speak in a particular language, he is having some set of rules, and then he can deal with the propositions, right? So I'm knowing something about the language, something rules about the language, and which I'm using it. There is no ambiguity in representation in logical representation, as it drives conclusion on the basis of various conditions. So I'm applying my logics. This is what is there. Because if I'm having knowledge and I want to represent it, so there are different categories under which we can represent this. Hello. Hello. Somebody has unmuted. Okay. So now if I want to represent, there are different categories in which the knowledge representation can take place. Now there are four techniques which we are going to see. Now how the knowledge can be represented? Obviously, there is a logical way to do it. There is a logical way to do it, means based on my knowledge, I'm applying my knowledge. I'm applying my logic. And based on that logical, I am driving the conclusion on the basis of various conditions which I am been facing. That is called the logical representation. Obviously, that is with some set of rules how to deal with about the propositions. Second one is semantic network. It's simple and easy to understand as these networks are natural representation of languages. Now let us understand how this network, how this knowledge representation takes place. So if you look at the first representation, It is about the logics. Now this is about the semantic. Now how semantic means what actually? It is the network of a labeled nodes and links which is used to represent information in the forms of graphical networks as well as to convey meanings in a transparent manner. So पहला जो था वो लॉजिकल था, अभी ये जो है ये सिमेंटिक नेटवर्क है. सो ऑब्वियसली कोई तो भी रिप्रेजेंटेशन है. सो हियर द इंफॉर्मेशन वी इज नो गोइंग टू रिप्रेजेंट इन द फॉर्म ऑफ ग्राफिकल नेटवर्क्स. This network is nothing but having labeled nodes and links. So a graph will be made of this network and that will convey the information. For categorizing the objects into different forms to linking objects, semantic network representation is crucial to the knowledge representation. Moreover, it consists of two types of relations. One is inheritance, which is also called as ISA relation, and second is queries, which is also called as a kind of relation. So based on these two crucial types of relationships, semantic network works. Logical representation is about applying your logic to reach to a conclusion on the basis of various conditions. Whereas in case of semantic networks, it is nothing but representation of the informations in the form of a graphical network, right? And how this semantic network is crucial as it tells about two types of relationships. One is an inheritance and the other one is the queries, that is kind of relation. Now this is how the semantic networks look like. Following are the statement which needs to represent in the form of nodes and arcs. So obviously, if we start with the statements, then Jerry is a cat. So what is been applied here? The first one, inheritance, that is called as the ISA type of relation. So here is ISA type of relationship because Jerry is a cat. But a cat is a mammal, so again ISA type. And mammal is an animal because all the mammals are animals. So again ISA. Okay, now the another sentence is Jerry is owned by the Priya. So Jerry is owned by Priya. It will be a different graphical structure. And Jerry is a brown colored. So you can see that white colored. So you can see that this is a white color. So because as these three are having some relationships, these two are not having, so they are independent. They are coming as this. So Jerry is a white color, whereas Priya is owning this owned Jerry. These are two different sentences. But Jerry is a cat, cat is a mammal, and all mammals are animals. These are having some kind of relationships with each other. So we can say that this is an inheritance and ISA relationship, whereas the other one is a query, that is just a kind of relation. This is a query type, and this is an inheritance type. As all the mammals are animals, so obviously you're going to get this relationship, which is also called as ISA type of inheritance, which is also called as inheritance relation. In the above diagram, we have represented different types of knowledge in the form of nodes and arcs. So you can have the nodes as well as there are arcs. Each object is connected with the another object by some relationship. Now, what is the drawback of semantic representation? Even if I'm using it, what is the drawback? Because as you know that there are some advantages, there will be some disadvantages also. It takes more computational time as we need to answer some of the questions. Hence, it takes a little bit more computational time at runtime. It might be possible in the worst case scenarios that traversing the entire tree, we may find that solution does not exist in the network. Yes, ऐसा भी हो सकता है. एक नेटवर्क आपको सब ग्राफ मिल रहा है, दूसरे नेटवर्क में रिलेशनशिप भी नहीं मिल रहा है, तो हम सारा ढूंढते बैठेंगे, इसमें इतना सारा टाइम चला जाएगा और कोई कंक्लूजन भी नहीं निकलेगा. सो ऐसा हो सकता है कि एंटायर ट्री में सॉल्यूशन ही एग्जिस्ट ना हो. Semantic networks try to model human-like memory. So obviously everything has been mimicking, the intelligence is mimicking, here the networks are also mimicking like human-like memory, which has 1015 neurons and links to store the information, but in practice it is not possible to build such an vast semantic networks. So you can just imagine how humans is having a complicated kind of neurons and linking of them. So practically, if you want to implement those kinds of network, you will require a very vast semantic network. So you cannot just mimic it, you mimic the human like memory completely. There are some limitations for that also. These types of representations are inadequate as they don't have any kind of equivalent quantifier for all, for some, for none. ऐसा हो सकता है कि हर चीज एडुकेट हो, ऐसा तो पॉसिबल ही नहीं है. कुछ रिप्रेजेंटेशन बिल्कुल इनएडुकेट हो गए, है ना. तो फिर उसका मतलब यह है कि उनके पास कोई इक्विवेलेंट क्वांटिफायर है ही नहीं टू क्वांटिफाइड. क्वांटिफाई मींस कि भाई एक पर्टिकुलर आदमी को अगर मैं क्वांटिफाई कर रहा हूं तो ही इज हैविंग वन, ही इज हैविंग टू. अब फॉर ऑल, फॉर सम, फॉर नन बोल तो कोई क्वांटिफिकेशन ही नहीं आती है. सो इट इज लाइक दैट. So it is inadequate in that case. Semantic networks do not have any standard definitions for the linked names. So link तो है लेकिन ऐसा कोई semantic network में कोई standard definitions नहीं है कि इसको ये दो, उसको नाम दो, उसको ये link को ये बोलो. These networks are not intelligent and depend on creator of the system. So it is not an intelligent system. It does depends on upon how the system is built up. It has some kind of advantages also, like natural representation of a knowledge, convey meaning in transparent manner, simple and easily understandable. It could be expressed in natural language. Production rule consists of pair of conditions and actions, whereas the action is always after the conditions. So this is how it goes like. The knowledge representation technique is highly modular and can be easily removed, added, or modified. Some of the advantages that goes with. Production rule consists of three parts: set of production rules, working memory, and recognize act cycle. We can take an example of the semantic networks. So what is if and then action? So if at bus stop and bus arrives, then action get into the bus. If on the bus and paid and empty seat, then action sit down. So first is the the path, and then what to be action taken, because here we what we are saying, set the production rule, work memory, and then recognize act and act cycle. If on the bus and unpaid, then action pay charges. If bus arrives at the destination, then action go down from the bus. So all these things are can be implemented through the semantic networks. The advantages of the production rule that can be used in semantics, as they can be expressed in natural languages, highly very modular, easily remove, add, modify individual rules, can modify. And disadvantage of the production rule could be that it does not exhibit any learning capability. जैसा बोला है वैसा ही करेगा, उसमें कोई learning capability नहीं होगी. During the execution of the program, many rules may be active, hence rule-based production systems are inefficient. So हमने पहले semantic network देखा, फिर semantic networks with production rule देखा. So दोनों भी techniques में with और without production rule और with production rule, दोनों के कुछ advantages है, कुछ disadvantages है. Then we'll go to the next one called as a frame representation. Frames are AI data structure that divide knowledge into substructures by representing stereotype situations derived from semantic networks. It is widely used in various knowledge-based systems and applications, and programming easier by grouping the related data. Now, frame representation is nothing but it is a substructure dividing the knowledge into substructure and then representing each substructure for a particular stereotypic situations. That means it's like grouping, and then you're doing the programming easier for grouping the related data. The advantages of the frame representation is that the representation makes the programming easier by grouping the related data, because you're making group and getting the related data together by grouping them. It becomes very easier. The frame representation is comparable, flexible, and can be used by many applications in AI. It is very easy to add slots for new attributes and relationships. So you can add attributes also. It is just not about that. It's just adding attribute and find their relationships also. It is easy to include default data and to search for the missing value. Then frame representation is easy to understand and visualize. There are some of the disadvantages of the frame representation. The mechanism is not easily processed. The mechanism cannot be smoothly processed by the frame representation, and it is much generalized approach. So this is not as such as good as like semantic networks or the earlier what we have seen. Now we'll be moving towards the last point of this lecture, which is the requirement of knowledge representation systems. So if I'm having a system and if I want to apply this knowledge representation and reasoning KRRs in that particular system, then it is very important that they consist of following attributes. Then only this knowledge representation systems can work properly. So there are some of the attributes that is needed in that system in order to have this knowledge representation system. The first one is expressiveness. That means the knowledge based language should be very expressive so that it can work effectively. Then comes accuracy, must be capable of representing all required knowledge. How accurately you can represent the knowledge. Otherwise, if it could be there like some of the knowledge you cannot represent, then accuracy may go down. Inferential adequacy. The system must be able to manipulate the representational structure to produce new knowledge corresponding to the existing structure. So when you apply an existing structure, there should be an adequacy that you can learn from that existing structure to build up a new one. That should be there. Then inferential efficiency, the mechanism to have most productive directions by sorting appropriate guides. Acquisitional efficiency, acquire new knowledge using automatic methods. It should be capable. Semantic clarity, it should have clear and well defined semantics. That is semantics we have seen, like all having the nodes and the linking and everything, that should be clear. Otherwise it becomes difficult for the system to identify. And meta reasoning means capable of introspecting on its own knowledge. This is by far actually seventh one is the most important, that what kind of knowledge representation is done and whether the system can able to introspect or not. If it is able to introspect, then we can go with the particular AI system. So this is what about knowledge representation requirement, what we have seen. So in the next lecture, we'll see the next part. Okay, so we'll take the attendance.